Namaste faculty members, I am Adarsh Pathak and I hope this video finds you in a sound health. Today I am going to give my seminar presentation on Docker. These are the table of contents or the flow of the presentation. So first we'll have some concepts, some initial concepts that actually inspired Docker as a platform and as an application. So first we'll talk about the virtual machines, then what are containers. After that, I will explain something about Docker, the advantages, the adoption rate, and the popularity of Docker. Then, what is Docker Engine? After that, we'll talk about the architecture, the essential commands of Docker. Then, we'll see some steps of downloading it, setting up the environment, and then testing the environment. After all these 10 steps, I'll show a simple demonstration to show how easy it is to use Docker, and we'll also talk about what we mean by containerization itself. So let us jump right into the presentation. So yeah, what is a virtual machine? See, a virtual machine is just an emulation of a computer system. You see, we have our hardware. On top of the hardware lies our hypervisor. Now, what is a hypervisor? Hypervisor is basically a software application that abstracts away all the complicacies of a kernel, creates a pool of all the hardware resources, and then it allocates or deallocates accordingly to the virtual machines. On top of the hypervisor are the virtual machines. In each of the virtual machines lies their own operating systems, and on top of the operating system runs our applications. And though it is a really great concept, but as you can imagine, the concept of virtual machine is really heavyweight. Though it was a revolutionary concept, but it was not really that much scalable. So after the virtual machines came containers. Now a container is a standard unit of software that packages up code. Essentially what a container is and how it works is you have the hardware given, you have a given hardware. On top of the infrastructure you have a host operating system, and then on top of the host operating system you have Docker installed, and after that Docker manages all the containers that you run. And as you can see, there is essentially no use of any operating system involved there because Docker uses the kernel of system itself, the host operating system itself. These all are the containerized applications. Now, what is the benefit of containerized applications apart from the virtual machines perspective? You see, a virtual machine required a hypervisor, a full-blown hypervisor, and on top of the hypervisor, every VM had its own operating system. But that's not true in case of containers. So you just need to install Docker or any containerization platform, and then that piece of software will take care of running, managing, or doing any sort of management activities with your containers. And containers are really powerful in the way that they are really lightweight, and you can run a lot more containers given a specific set of hardware than virtual machines. So obviously they are a lot more scalable as well. After the container comes the Docker. So what actually is Docker? Docker is an open platform for developing, shipping, sharing, and running applications. Open platform because Docker Community Edition itself and the software itself is an open source software. Though if there are some enterprise users, they can opt for the enterprise edition in which they get enterprise support from the Docker company itself. So what Docker enables you is you can separate your applications from your infrastructure so that you can deliver the software really very quickly. So just using some piece of code, Docker enables you to develop what is called an IAC, that is called infrastructure as a code. What that piece of code does is it can create your entire infrastructure, including what operating system you use, what servers you use, what dependencies you use for your application to run successfully in a given environment. You can create that entire environment using some lines of code using Docker itself. So this is the process of containerization. This is the process of containers. You can run these isolated containers. One container may contain the database service. One container may contain your application, which is written in Python, .NET, or even Java. One container may contain your caching service. So that is the purpose of containers. All the containers are isolated from each other so that if any application misbehaves in a single container, then that does not affect the rest of the containers that are running in parallel to that particular misbehaving application in that container. So that's why the containerization concept is so important and so robust. As you see, the pandemic is there. The government is also trying everyone to maintain social distancing. And the purpose of social distancing is to isolating yourself. So obviously, isolation comes with security, provides security, and thus the Docker provides security by default. Although there are a lot more to security, but still, isolation is in itself a lot more secure. You see, real Docker adoption is up to 30% in 1 year. This is actually a bit old data, but still you can get the idea. It is nowadays available in a lot of applications. Top technologies are running on the Docker. Two-thirds of companies that try Docker adopted within a month. Let's see some graphs. So this is the usage among the adopters. Docker deployment size has increased 75% 1 year. You see, in 2015 this was the deployment size 16. It is increasing per year. This is 2018 data. This is the adoption status by infrastructure size. It is this much popular because earlier the concept of containerization is not really new to the Linux ecosystem, the GNU Linux ecosystem, because in Linux we already have a concept of caging. But the issue was there was a really big expertise gap between who could understand and implement caging in their applications and who could not. And Docker really bridged that gap. So nowadays, even you can build your own containerized applications using Docker. So that's why Docker became so much popular. This is also the top technologies running on Docker. From top, Nginx, Redis. Redis, it's a caching service, it's a reverse proxy and web server. In the demo, I'll be demonstrating this Nginx service itself. So we saw the popularity of Docker and the various reasons behind it. Let us understand the engine that is powering this entire system. We have a Docker engine. So it has really three parts. The first part is a server which is running which is essentially running a daemon process. A daemon process is actually a long running process that keeps running in the background and acts according to the command given to it. On top of the daemon lies a REST API. The REST API is used to talk to different parts of programs within the daemon. So the Docker engine itself does the work of distribution, orchestration. Orchestration means managing a lot of running containers in an efficient manner, switching them on, scaling them up, these kind of stuff. Then we have volumes. Volumes are the same as in operating system volumes. We have the partitions of hard disk. Those are all the volumes. Then we have container D. We have Docker build command. Then we have networking itself, because obviously we need containers. Docker actually provides all the essential resources which an application require to run efficiently. So obviously an application which you have developed may make use of networking applications. So here it is Docker providing the networking applications to you. Your applications may need to store some data to the disk, so you have the volumes here. Then we have the distribution. So on top of the REST API lies a command line interface that actually talks to the REST API. So all the commands that we give through the command line interface sends the commands to the daemon process, which acts accordingly, and then depending on the command we may get any response back in a JSON format. This is a simple Docker architecture. So what actually happens is you have a client. These are the three essential commands: Docker build, pull, and run. Using pull, you can fetch the images. Now what is images? You see, you install an operating system using the installer provided to you. You can think of that installer as an image. These all applications have their images which you can download and then you can run using that run command. Docker build actually compiles your images. Docker pull pulls an image from the registry, and Docker run runs the image in the form of containers. So this is the Docker host. So the Docker daemon is listening to all the commands through a REST API, and then it manages the images and containers. The images after pulling gets run into the containers, and then here is the registry which contains a lot of different images. Now these are the essential commands that one needs to keep in mind. After the command, let us dive through some practical steps of how we can set up Docker in our own environment. So first of all, you need to head over to the Docker main website, and there you will be presented with these three options. And after you have downloaded the Docker, you can simply install it, and when you have installed it successfully, you can just type this piece of code. Let me run my Docker itself so that I can show you the demonstration. So you can check the version of your Docker using this command. After setting up the Docker environment, you can actually test the environment itself by running a simple program. So this is a demo time. So I'll show you the demonstration of using the Nginx, which is both a web server and a proxy server, which will be showing a simple static web page directly from the host computer via the container. So we'll see how it proceeds. So let us jump to the console. First, let me check the version of Docker. So yes, so I have the version. So I'll really show you a really good example of checking how you can check the Docker. See, Docker run means running a container. Slash this flag means run it in an interactive mode so that you can give commands directly from your computer. This flag is used to remove the container as soon as you are out of it or you have exit from it. You remove the container. Now we'll give it a name, demo, and I'll write one registry name. Okay. So if I have this image locally, it will directly run it with these flags, and if I don't have, it will first pull it from the registry and then it will run it. So let's check the demo. What happened? Oh, so yeah. So this entire thing is running inside a container and it's not running directly on my host. This is running inside a container and it is running in an interactive mode. That's why I'm able to see this output. And because it is running in interactive mode, I can just exit out of it using Control C. So now I'll show you how to create a container using an image of Nginx, which is a web server, and serve the static content from my local directory, from the directory of my host. Now let me show you. I'm currently in this directory, seminar. Okay, and seminar is containing an index.html. So let me quickly, let us see the contents itself. So this is a simple HTML file. It has just the title and that's it. So the web server in the container will be hosting this file without me copying this file explicitly to the container. Okay, so let us see how it works. So I'll write docker run name server. I gave it the name server. Then I'll specify the port 8080. What does that mean is the container will be listening at port number 80, and the port number 80 of container will be mapped to the port number 80 of my host, so that when I locally, when I try to check host number 80, it will redirect me to the host number 80 of container itself. So this type of networking is taken care by the networking component of Docker daemon. Okay, so after it I will add a volume. Now as you know, pwd is used, it is a variable here because I'm using fish shell. Using this command will append the present working directory here, which is this, so that my index.html file from the host is made available to the container, and I will map this to user share nginx html. So basically this is the path where the nginx stores the files. Arrow means that I only want this volume to be read only, so that I don't have to deal with the permission issues. And after that I will add /d. D means in a detached mode. /d ensures that you are not provided the shell access and the container runs in a detached mode as a daemon, okay, in the background. And then I will type nginx as the name of the image. So by default it will go to the Docker registry and pull that image if I don't have this image locally. I will press enter, and This is the checksum of that image showing. You can use this checksum to kill that image, to stop that image, and to do various kind of steps. You can also use the name itself. That's why we give every container name, because by default the Docker gives random names to all the containers. Let us check docker ps/name. As you can see, 24 seconds ago container is created named server. In the container it is running on port 80, which is mapped to our port 80. Okay, so as we saw, our server is running and it is mapped to port 80. So let us see, let's have a look at the server, localhost port 80. So as you can see, this is our web page, I think. So let us open our web page and do a bit editing. Let me add some content here. Probably after the body I'll add h1 namaste world. Okay, and I'll close it. So that's it, simple modification. I am making this amendment in the host itself, and now the web server running in the container will show changes. So I think you must be able to appreciate the beauty of this software and how easy it is for anyone to use it. Okay, I mean, I have all the reports there in the report file itself as well as in the presentation. You can check the commands. You only need to remember the commands, which are really, easy. It's really simple. But using those simple commands, you can think how much powerful toolset you can get. So you see how powerful is the Docker, and it is using a simple concept of caging from the Linux file system. But that's where the Docker innovated, by bridging the gap of expertise so that anyone can use this powerful concept. And I think that's the idea of science, to bridge the gap so that the science is available to one and all. That's the whole purpose of education and innovation, I think. So I hope you are able to appreciate the beauty and the power of Docker, and I'm really sure that you will give it a test drive and have fun with it. These are some of the references that I took the help of while creating this presentation. Thank you so much for being so patient, and this was my presentation on Docker. Thank you.